Hey everyone, yes I'm back, and I'll be going through complex numbers before I delve into our lovely chapter of vectors. And to start, this is just an introduction to complex numbers. So you probably heard about other numbers, right? Real numbers, integers, and all that stuff. I'm just going to focus on real numbers as a way to contrast between complex numbers and real numbers. So we have some examples of real numbers. We have root 5, minus 5.6, and some fractions as well. Let's say 12 over 27, for example. All these are real numbers because they actually exist. They do have a particular value. You can evaluate them. On the other hand, when you talk about complex numbers, we are going to introduce the idea of an imaginary number. Now, what this does is when you have an imaginary number, it means that you have no value at all. It is quote unquote meaningless. It has no value whatsoever. You can't evaluate the value. And what comes to mind, right, other than the symbol I, is the value of root minus 1. The idea is that, square root of a negative number, there's no value at all, right? We know that if x squared, this must be at least bigger than or equal to 0, right? It is never negative, right? It's either 0 or positive. But now we have root minus 1. Clearly there's no value at all. And hence what they did was, okay, let's make a new branch of mathematics out of root minus 1, the square root of negative numbers. So this is the core concept or the core idea behind complex numbers, where we're going to be looking at I, root minus 1. And the most common form, or the most common way to actually really represent this number, the first one that you learn is called the Cartesian form, where it's a mix of a real number and an imaginary number represented by a plus bi, where we have a this is called the real portion, re for short, alright, and then b, because it is next, is a scalar of the imaginary number I, we call this the imaginary part. So you have real part and imaginary part, short form IM. Alright, usually the letters representing complex numbers, Z, W, but really anything's possible. Alright, so if you have real of Z, it will be equals to A, the imaginary of Z equals to B. Alright, so take note of this notation as well. Now you realize that, hey, this is basically the core concept of complex numbers. You realize that all numbers can be represented by complex numbers, right? Real numbers are also complex numbers, right? You notice that, hey, I can represent it as plus 0i plus 0i. So in fact, if I were to, let's say, draw a relationship through let's say a Venn diagram, right? So this whole oval is a complex region, and then within this complex region, let's say I have this portion of real, you notice that, hey, the actual real numbers are actually part of complex numbers, just that their imaginary part are 0. Whereas not all complex numbers are real numbers, right? As long as you have an imaginary part, it's no longer a real number because there's no value of a complex number. Alright, so this is the whole idea in complex numbers dealing with the letter I. Other than that, what else do I need to introduce to you guys is there's actually a way to represent complex numbers. Alright, just like the Cartesian axis, we have the Cartesian form a plus bi. Why do we call it the Cartesian form? Because we can represent it as x plus iy on a particular diagram called the Argand diagram that is unique to complex numbers. Now, x and y, very familiar variables, right? Found in your Cartesian plane. X is the horizontal axis, and this is the real part, right? So as you can tell, since x is the real part, our axis is labeled as RE. Likewise, you can probably guess it already, this is our imaginary part as our y variable on the vertical axis, Again, origin is at the origin. Now, let's say we have the complex number 2 plus I. Alright, the real part is 2, imaginary part is 1. So we have coordinates 2, 1. So let's say somewhere around here. Let's say we have, minus 3 plus, for I, coordinates are minus 3, 4. So we have minus 3 on the real, 4 on the imaginary, somewhere around here. So this is the whole idea and sort of introduction to complex numbers, where we talk about what is the value of I, which is root minus 1, and why is it complex? There's clearly no values at all. Talk about Cartesian form. The first one they're going to learn, as I've shown you just now, very basic, A plus BI. Then lastly, the Argand diagram that is exclusive to complex numbers. And we're going to use this diagram to explore the two other forms to represent complex numbers. Otherwise, this is a simple introduction, and I'll see you guys in the next video.